All right, let's get straight into it. Today, we are dissecting something truly remarkable. We're looking at Quality Air OS. Now, this is a bespoke, highly complex business operating system, and it was built completely from scratch for a 22-year-old residential and commercial HVAC company out in Philadelphia. I mean, this isn't just some off-the-shelf app. It's a completely custom-engineered digital nervous system created by the founder's son to literally run every single aspect of their operations. Okay, let's really dive into this because the ambitious North Star principle driving this entire code base is just fascinating. The rule is, if a human does it manually, the system isn't finished. The builder here didn't just want to turn paper forms into PDFs on a screen, you know? The goal was full agentic automation. If a human being at Quality Air has to manually copy a number, check inventory stock, or try to guess a profit margin, this software considers itself incomplete. So here is our blueprint for understanding exactly how they pulled this off. We'll start with fixing a fragmented business, look at the architecture and security tiers, explore the 3 user surfaces, break down the rules of money and math, and finally, look at the AI-powered brain. Section 1. Fixing a fragmented business. To really appreciate the solution, we first need to understand the incredibly messy reality of how this business actually operated for its first 2 decades.
For years, the foundational bottleneck was just data compilation. The business was strung together across more than 6 totally disconnected systems. You had Dispatch.me for scheduling, QuickBooks for accounting, Gmail, Google Drive, physical paper. Actually, scratch that. The most dangerous system was just human memory. Quality Air OS solved this by replacing that whole fragmented web with a single, unified database in Superbase. Suddenly, boom, there is only one source of truth for the entire company.
So, the crucial point is that in this unified system, the work order is the literal atom of the business universe. Everything revolves around it. Dispatch reads a work order as a schedule. A field tech reads it as a job they need to complete. Procurement sees it as materials needed, and finance reads it as a profit margin. Every single financial roll-up is computed instantly on the fly whenever you pull up that work order.
Section 2. Architecture and security tiers. Let's move from the concept to the code itself and look at the technical skeleton that keeps this massive application upright, lightning fast, and most importantly, secure.
So we're definitely not talking about legacy enterprise software here. The builder explicitly ditched their old localized Mac Mini prototypes for a modern web-only tech stack. We're talking Next.js 15, React 19, and TypeScript 5.6 on the front end, hosted on Vercel. The backend is entirely Superbase, utilizing Postgres databases with pgvector for advanced AI search. And amazingly, the whole thing is completely browser-based. This means this massive powerhouse can be accessed and updated from literally anywhere instantly. But of course, with global access comes the absolute need for paranoid, rigorous security. The system operates on a super strict T0 through T6 access model. T0 is your super admin, the system builder, who can see and change everything. A T2 office manager can manage daily operations but is completely locked out of finance and HR. T4B is your standard W2 field technician, who can only see the specific jobs assigned to them. And a T6 customer only has access to a highly restricted portal with absolute zero access to the base database tables. Now you might be wondering, why do these specific tiers matter so much in the real world? Well, because of human nature. Without strict row-level security, or RLS, gating pay data at the database level, a technician could theoretically log in and just give themselves an unauthorized raise by altering their day rate. That would completely skew the project costs. So the database literally has triggers to block non-admins from promoting themselves, and it completely hides subcontractor pay rates from standard field workers. Section 3. The 3 user surfaces. Despite having all these different roles, the way the software is actually delivered to them is super clever.
Now, what's really interesting about this is that there is only one single shared code base serving 3 completely distinct user experiences, and it's based purely on web routing headers. If you go to the admin domain, you get the Office Console desktop. The technician domain gives you a mobile-first progressive web app. The client domain serves up the customer portal. And if someone tries to spoof a host or access an unknown route, the system safely defaults to failing open to the lockdown Office surface, where their access tier will immediately block them anyway. It's just a brilliant defense-in-depth strategy.
Out in the field, technicians are governed by what the system calls mobile law. Basically, one screen equals one job, with only 1 or 2 taps required to get things done.
But here's the real kicker. HVAC techs often work deep in concrete basements with zero cell service, so the app has to be fully offline tolerant. A tech can complete workflows, log parts, and take notes completely offline. The app just saves those actions locally into an outbox via IndexedDB, and the exact second their phone hits a cell tower again, it syncs everything seamlessly back to the main server.
Section 4. Rules of Money and Math. Let's transition over to the financial nervous system of Quality Air OS, because a core philosophy here is that financial logic should be hard-coded and computed on the fly, not typed in manually by a person.
So, the system ensures the company automatically maintains perfect margins and stays in complete parity with QuickBooks by using strict immutable math rules. For example, parts and equipment are always marked up 2.5 times the cost. Labor is marked up 2.0 times a tech's day rate. And notably, they are paid by the day, never hourly. There are fixed baselines for service calls, like $125 for residential and $165 for commercial. And, like we touched on earlier, these financial roll-ups are computed every time a user reads the data. They are never stored as static numbers. That means a change in a vendor bill instantly updates the final profit margin of a job across the board. If you're building a business app, this is a massive takeaway. Compute your math on the fly. Don't store it. I really want to emphasize this specific number for a second, $125. In this system, this is hard-coded as the return call loss. If a technician makes a mistake and has to be sent back to a property to redo incomplete or wrong work, the customer pays nothing. The company automatically eats this $125 fixed loss, and the system immediately surfaces it in glaring red on the financial dashboards. It forces absolute, undeniable accountability.
Section 5. The AI-powered brain. We have reached the absolute climax of this explainer. All of this pristine data and strict structure lays the groundwork for the most cutting-edge part of the OS, the multi-LLM router operating silently behind the scenes.
And this brilliantly illustrates how a modern AI layer should actually be integrated into a business. It doesn't just lazily rely on one single model for everything. Instead, it dynamically routes different AI tasks to the most cost-efficient and capable model available. Super-fast routine tasks? Those go to Grok Llama 3.3. Deep, complex reasoning goes to Anthropic's Claude Opus. When a vendor emails a messy PDF invoice, Gemini 2.5 Pro visually parses the document to extract the data. And sitting right on top of all of this is Hermes, an internal AI assistant that employees can query, which knows the entire state of the business in real time.
Now, a massive risk with AI is hallucinations, right? Especially when you're pricing out customer estimates. So the builder created this estimator team pipeline featuring 4 distinct roles with strict checkpoints. First, a cheap AI acts as the parts scout to extract search terms. Then, a deterministic price analyst takes over. This isn't an AI, but a hard-coded rule that checks the actual historical purchase database so the AI literally can't invent costs. Third, a complex LLM acts as the estimate builder to structure the draft. And finally, a deterministic margin reviewer flags any thin markups. It's this perfect blend of AI speed with hard-coded mathematical safety.
Furthermore, keeping a database of this size clean is just an absolute nightmare. Enter the maintenance crew. Because, let's be honest, no human actually wants to do database cleanup. This is an autonomous cron agent running in the background every single day. It acts like a digital janitor, constantly scanning the database for orphan data, mismatched invoices, or conflicts. It applies safe, reversible auto-fixes all on its own, and if it finds something ambiguous, it sends a quick alert to a human operator asking for a decision. It does the tedious busy work so humans just don't have to.
Let's step back and see how this builds across the project timeline. Because what is truly staggering here is the absurdly fast development speed. The concept master plan was locked in late May 2026. By June 3rd, the foundation was scaffolded. By June 25th, the AI-powered accounts payable pipeline was already live. And by July 19th, the complete AI estimator team had shipped. In less than 2 months, a single developer built an 80% production-ready, massive enterprise operating system perfectly tailored to one specific HVAC company.
It really forces you to step back and look at the future of work. When you have a bespoke operating system where the AI handles the math, writes the estimates, parses the invoices, and does all of the tedious data entry, what human skills become the new bottleneck in your business? It's a fascinating reality check on what happens when software finally stops being just a tool you use and starts being an agent that works right alongside you. Thank you so much for joining me for this explainer.